trying out something here. I've got it's a cheap action cam there, which isn't I don't know if it's going to work, but there it is, and it's just to record me while I'm doing stuff. So what I've done here is I've actually overplotted so the cyan line is the total voltage, which is from this column here, and you see currently it's on 11.4. Now what I've done is also as well, and you can see it's just coincidence that it happens to be there, but what it does, I think the genumeric basically puts that so that it's roughly central, you see, and so you can see, so it's just coincidence that it happens to be with the one that charged. I'd have to do the calculation better. I mean, I guess if you just, so it's 4.2, so 3 times 4.2 is 11.6, I think. 3 fours are 12, obviously, and then we got 3 2, so it's 11.8 actually. Is that right? No, it's not. It's 12.8. It's 12.8. Of course, it's 12.8. 4.2 being the maximum voltage cell. 12.8 for 3. All right, for 3 cells. Okay, so 12.8. Yes, 3 fours are 12. Which means it's it's 12.6, sorry, 12.6. That makes more sense. 12.6. But the actual top of the graph is 11.7, so those don't marry up correctly because it's 3 cells. And then we got 3.4 down here. That would be 3 fours, 3 threes and 9 plus 1 is 10, so that would be 10.2. Yeah, 10.2, and it's 11.1, so it's actually offset. Okay. So the ranges aren't coincidental. Yeah, you can see it kind of follows the line of the lower cell to some extent, but there's a bit of a knee here. And this is where things start crossing over, I guess. Obviously, a lot of noise in the readings, which really needs to be resolved out. But that's the way it is right now. What I've done is I've actually turned on the power pack again and put it on the 1 amp charge. And I've set the constant voltage to 12 volts now because we actually have better balancing, and so we're not in. This was the one I was wondering about because that's obviously high. Now it's still high, but we have better balancing now. This one actually is above this, so really we should be balancing it the other way now and getting this one up. So I might actually reconnect it so that it's actually charging this one instead with the cell balance, because that's the lowest one, and obviously we're doing battery to cell, so you pick the lowest one and charge it all the time. So as what happened is, as this one actually passed it, in other words at this point here, right, what we should have done is charge that one up to the average, picked the average off and charged it up to the average, which I guess it roughly is now. But because this one is now down below the average, we then switch to that one and charge that one up, and obviously we have a new average. But we calculate the average every time we do the reading, and so it's a constant thing. Yeah, and until this one hits the average. So that's what we would do if we were actually doing this for real, to do cell balancing. Yeah, I've set it at 12 volts, so with a bit of luck, and we can see right now that it's on 11.4. Okay, 11.4, 11.5. It's actually reading 11.5, and since that is mathematically correct because it's above it, although sometimes it dips below it, so I think it's okay. And we'll see what it does now because it's charging them all. Yeah, and we're continuing to put charge into this one now, but that is actually set to 4 volts. So once that hits 4 volts, then the cell balancing circuit won't have any effect because it's beyond 4 volts, you see. So if that one charges up to 4 volts, then it'll stop charging it. I'm presuming this one's going to get to 4 volts as well, so that the lame duck will be this one. But this is where you need something that can actually change the cells, so as to charge the cells, and we don't have that right now, so I don't know. Anyway, that's where I'm at the moment.